Selecting an industrial balancing machine is a decision that defines your floor's operational capacity. The choice requires a precise alignment between the machine's internal architecture and your specific daily workflow. If the machine's structural design fights your primary tasks, you create a persistent technical bottleneck. This mismatch leads to high capital waste and a steady accumulation of unfinished work as the equipment struggles to keep up with the intake. Most solutions on the market fall into two distinct engineering categories: soft-bearing and hard-bearing machines. Neither architecture is objectively better than the other. The goal is to match the mechanical traits of the system to your specific business model. This quadrant chart illustrates the divide. The x-axis tracks rotor variety, and the y-axis tracks production volume. Soft-bearing machines are designed for the high-variety, low-volume sector, while hard-bearing systems occupy the high-volume, low-variety corner. The decision for any facility manager comes down to a single priority. Do you require extreme adaptability for diverse parts, or do you need standardized repetitive speed? Soft-bearing machines are the primary tool for maintenance and repair shops. These environments deal with low volumes of parts, but those parts are rarely identical. Pendulum mounts with flexible roller supports dynamically self-align with the rotor. This permits the use of flat rollers, which minimizes friction and prevents rotor damage. This elastic design also maintains full measurement sensitivity, allowing accurate balancing at slower, safer rotational speeds. Because the flexible mount requires extra steps for severe unbalance, you may need a static balance first, or physically lock the base to prevent excessive movement. The defining operational characteristic of this machine is the trial weight method. The trial weight method requires running a self-calibration cycle for every unique rotor. While providing extreme versatility, this initial setup process is highly time-consuming. However, using single-run calibrator tools can automate these tests, reclaiming some time despite the per-rotor limit. Ultimately, the soft-bearing machine trades rapid, repetitive output for the flexibility to handle a queue of unique or damaged rotors safely. For mass manufacturing lines, the requirements change. When the priority is high-volume output of identical parts, the hard-bearing machine is the standard choice. These machines use a heavy-duty frame permanently bolted into a specialized concrete foundation to operate correctly. This rigid construction allows the machine to immediately process parts with high initial unbalance. There is no need for pre-balancing. The machine simply absorbs the massive forces. Rigid frames cannot self-align, requiring crowned rollers that reduce the rotor contact area to a pinpoint. Over long production cycles, this concentrated contact generates localized pressure, leading to faster wear and potential surface damage on the parts. Furthermore, this rigid frame introduces a strict speed requirement. Because the rigid frame restricts vibration amplitude, the machine must run at much higher speeds to reach the necessary measurement sensitivity. Instead of trial weights, calibration relies on pre-calibrated ISO standard test rotors. Once calibrated, the machine can process hundreds of identical parts back-to-back with a significant speed advantage. Hard-bearing machines are highly efficient for standardized production, but they are physically inflexible. Changing the setup to accommodate a different rotor shape is a major technical hurdle. When making your final decision, do not focus on maximum RPMs or complex technical specifications. Focus purely on your operational bottleneck. Weigh your required daily production volume against the diversity of the parts you handle. For a manufacturer testing standardized, identical rotors all day, a hard-bearing machine is the logical investment. This allows identical parts to move through the balancing stage continuously, seamlessly supporting high-speed automation without recalibration delays. However, for a repair facility where the intake is unpredictable and the parts arrive in various states of repair, you need a different tool. The soft-bearing model is the essential choice here. The time required for the trial weight method is the price you pay for the ability to accept any job that enters the shop. It also ensures that your maintenance team can balance heavily damaged or unknown rotors safely at low, controlled speeds. This flowchart summarizes the decision. Start with your primary operation at the top. The manufacturing path on the left prioritizes eliminating per-unit processing time to meet volume quotas. The right repair path prioritizes flexibility, ensuring adaptation to any rotor requiring service. The most effective capital investment isn't the machine with the highest raw specifications. It is the one whose structural compromises align perfectly with your facility's daily workflow.